Hi everyone. So today we're going to talk about alkene. We're done with alkanes. Okay, so alkane was about carbon-carbon single bond, uh, composed of carbon and hydrogen. Alkene is also composed of carbon and hydrogen. However, the difference here is that you have carbon-carbon double bond involved. So you need at least one carbon-carbon double bond in order to qualify as an alkene. Other than that, people call this unsaturated hydrocarbon. Okay, we'll talk about unsaturation or unsaturated hydrocarbon, dehydrogenation, stuff like that later on, because alkene is pretty important in terms of oil making industry. The general formula is CnH2n. Now the problem with this is that it doesn't work for all alkene. So later on when we have multi-substituent alkene, this formula doesn't work. Okay, but for today, it'll be fine. Tomorrow, maybe not. Yeah, maybe not Wednesday. Wednesday we'll take a look at polysubstituted alkene. So for today, let's take a look at regular alkenes, naming some of these regular alkenes, and hopefully by the end of the day, we learn how to name alkene with subgroup. All right? Okay, let's move on. I have this table. Okay, hopefully you've drawn the same thing in your notes. So N stands for number of carbon. CF stands for chemical formula, which we know already is pretty useless. SF is not Street Fighter, is structural formula, which I don't want you to use. This is what I want you to use. Condensed formula. And of course, the name. So let's move. N equals to 1. Come on. N cannot equal to 1. How can you make a 1 carbon alkene? That makes no sense. And we'll start at 2. Right? So following the general formula, the chemical formula will be C2H4. Okay? The structural formula for C2H4, well, you're going to have carbon double bonded to a carbon. Don't tell me that carbon is going to double bond to a hydrogen. Every carbon makes 4 bonds, right? So here it is. Okay? This carbon is double bonded to this carbon, which is single bonded to these 2 hydrogens, and so is this guy. So this is the most simplest alkene. Now, condensed formula wise, how am I going to illustrate this? Just like what we did with alkane. We have carbon bonded to the amount of hydrogen, and then we're going to make a double line which indicate that this carbon is double bonded to another carbon, which is also connected to 2 hydrogen. So that's how you write the condensed formula for this little guy right here. Now, name. Hopefully you guys are comfortable with those organic prefix. Again, the number of carbon is F. This is an alkene functional group. So I'm pretty sure that the name is called ethene. Okay, so once again, F because of 2 carbon, ene because of the alkene functional group. How does that sound? All right, let's move on. How about N equals to 3? Giving me a general formula of C3H6. The C3H6 looks great. And structurally, let's draw the carbon-carbon double bond. Okay, because you're going to have at least one of these connected to another carbon single bond wise, and let's add in those hydrogen. Be careful when you add the hydrogen. Okay, carbon only makes 4 bonds. So here it is. There's C3H6, right? 3 carbon, 6 hydrogen. So to draw this condensedly, we are going to do CH2, double bond, CH, CH3. I wonder what the name is. 3 carbon, huh? 3 carbon means probe. This is an alkene, so propene. You see? Now you may be asking, or maybe thinking, does it matter where the double bond is? Can the double bond be between these 2 carbon? Well, let's draw that. Let's draw that. You don't have to draw it. I'll draw it. And I'll show you. Sure. You can have this. But if you think about it, if you were to flip this backwards, okay, literally flip it backwards, it looks just like this. There's no point. Okay, these are the same thing. Now, we saw how alkane have so many isomers. My goodness. How about alkene? Do alkene have just as many? Do alkene have isomers? You can bet your bottom dollar that it does. Oh, yes, it does. Check this out. Okay. This one will have isomers. N equals to 4. C4H8. Okay. So C4H8. 1, 2, 3, 4. There's your 4 carbon. Double bond. Let's say between the first carbon and the second carbon. Let's add in those hydrogen. Making sure that everybody has 4 bonds, because if you don't, you'll notice that you might not get H8. Okay, so be very careful. Now, I'm hoping that you can just jump right into the condensed formula by now. But if you cannot, no big deal. Still have lots of time. All right. 1, 2, 3, 4. 4 is but. Okay, this is an alkene, so butene. Butene. The problem is butene is not good enough. I'm sorry. Butene is not good enough. You say butene, people is going to ask you, what butene? What do they mean? They mean that butene can also be expressed like this. Here's your 4 carbon. Why can't I have the double bond between the second and the third carbon? That's different than this. All right? Let's add those hydrogen. There should be 3 here, 1 here, 1 here, 1 here, 1 here, 1 here. Okay? So this will be CH3, CH, double bond, CH, CH3. These 2 are the same structurally. The only thing different is where that double bond is. Because of that, this molecule is completely different in terms of their chemical and physical property. It's a big deal. They have different names. Now, to name these alkene, you indicate exactly where that double bond is. And you want the double bond to inherit the lower number when you number your carbon chain. So you would number it this way. 1, 2, 3, 4. Okay? So the real name for this guy is called 1-butene. Why? This 1 is indicating that the double bond is between carbon number 1 and number 2. You pick the lower number to indicate. Which means this is 2-butene. You see? Pretty sick, huh? You may be thinking, hey, I get the idea. Check that out. Look at this. 3-butene. Right? I don't think so. If you flip this around, right? If you flip this around, it looks just like this. There's no such thing. Right? You can renumber this way, and it will only be 1-butene. So, forget about it. So there's 1-butene, 2-butene. Now, is that it? I mean, 2 isomers? No, we can do this. Okay, put the 4th carbon down here. Still fine. You look at this carbon. Look, this carbon has 4 bonds. He's not going to have any hydrogen attached to it, but no big deal. Because I can have hydrogen attached to these places. These places are happy to have hydrogen all over. Look at this. 1, 2, 3, 4, 5, 6, 7, 8. This is still C4H8. Right? CH2, C, CH3, coming down here, CH3. This is still C4H8. This is still an alkene. Do you think it'll be called 1-butene? I don't think so. There's nothing butene about this guy. Right? Strategically, how are we going to name this? Well, just like what we did with alkane, you want to find the longest carbon-carbon chain. But this time, because of that double bond, your longest chain must incorporate double bond. So it won't be this. That's for sure. It has to be this. Or this. That's fine too. But let's just look at this. That's your longest carbon-carbon chain. And guess what? You want to make sure the double bond inherit the lower number. Not the side group this time. No. Not the side group. Double bond takes priority. Later on, we're going to have a priority table. In this priority table, you should note that some functional group are more important than others. Okay, alkene is more important than alkyl. He deserved a lower number. That's how you would number it. And just like that, you can start naming it like how you would name alkane. Okay, name those side group alphabetically. Okay, in this case, it doesn't really matter because there's only one side group and it's connected to carbon number 2 and it's a 1 carbon side group, so that's 2-methyl. And then name your longest chain. Okay, now some people actually put 1-propene and some people just put propene. Doesn't matter. Why? Because it can't be anywhere other than 1. Okay, the double bond is not going to be between here. Even though if it is, flip that around, that's still 1-propene. So this cool guy right here is called 2-methyl 1-propene. Now, some people might say 2-methyl pro-1-ene. Put a 1 here. Okay, in some textbook they do that. Hopefully, we'll see some of those. Okay, and we will see some of those actually when we have multi-substituents, something that you don't want to see this week, but you will see next week. Okay, where you'll see this 1 being placed right here. All right, so C4H8, really only 3 isomers, that will be a lie to you. Okay, that will be a lie to you. You'll notice tomorrow I will have 2 more isomers. Okay, not 2 more, maybe 1 more isomers. It has something to do with this guy. Okay, geometry wise, I can split this into 2 more. Okay, so there's actually 2 more 2-butene, but let's not talk about it today. It's Monday. Okay, you don't want to learn about that on Monday. You'll learn about that on Tuesday. Okay, it's called geometrical isomers. You might have seen it before in biology, like D-glucose and L-glucose. What's the difference? Well, you would say, hey, carbon number 1 is flipped. Same idea. Okay, we'll look at that tomorrow. Let's not worry about that now. All right, let's clear this page. Let's do 5. Okay, so we have C5H10. So, let's take a look at all the isomers involved. Name them. So, C5, so let me have a 5-carbon chain. Let me make sure that there is at least 1 double bond, and that will be between 1 and 2. Let's add those hydrogen. And yes, I'm doing structural formula, which is the last time you're going to see it. Okay, on an alkene. All right, so this is going to be called 1-pentene. Do you think there's going to be a 2-pentene? Absolutely. Of course there is. There you go. 2-pentene. Do you think there's going to be a 3-pentene? I don't think so. You flip this around. Or you do, or, yeah, you draw this. Let me draw this. Don't draw this. I'll draw this. Okay? Flip this around. It looks like this. There's no 3-pentene. It's only 2-pentene. But can I start adding side groups? Oh yeah, why not? Why not? Let's go back to blue. Let's do this side group. A 4-carbon side group. Still, the double bond is between 1 and 2. Okay. Where I'm going to put the 5th carbon? Am I going to put it here? No, that would be quite ridiculous. Okay, because if you put it there, that will be your longest chain. Okay, the side group is between 2 and 3. That's this guy. I don't think so. Just like last time in alkane, we never put a side group in carbon 1. The only time that you see a side group stemming out from a carbon 1 is cyclic. Well, cycloalkane is the only time you'll see 1-methyl something, 1-ethyl something. You never see in a straight chain alkane, I can tell you that. Now, this is logical. Okay? There you go. Let me draw those hydrogens. Okay, this is C5H10. Okay. How are we going to name it? Well, obviously this is your longest carbon-carbon chain, and it does involve double bond. You make sure that the double bond is inheriting the lowest number. So here it is. So you would say this is called 2-methyl. Okay, so I'm talking about this guy. 2-methyl 1-butene. The 1 in this case is very, very important because you're going to see 2. All right. Now, we're not going to let 1-butene go. We're going to continue with this 1-butene business. I'm going to draw this again. Here's another 1-butene. But this time, I'm going to put my side group here. Is there a difference? Of course there's a difference. Structurally, it looks very different already. Okay. So here's my longest carbon-carbon chain, and here's my numbering, making sure that the double bond inherit the lower number. Okay, not the side group inheriting the lower number. Okay, but the double bond inheriting the lower number. So, which means the side group is stemming out of 3. So, hey, this guy is gonna have a different name than the one on top. This is not 2-methyl 1-butene, but this is 3-methyl 1-butene. How cool is that? Hey, is it going to be 4-methyl 1-butene? Okay, you do it. I don't think so. Okay. In terms of butene, I think this is it. Okay, that's all the butenes there's going to be. Well, at least 1 butene. So let's take a look at isomers involving 2-butene. So here's 2-butene family. Here's butene between 2 and 3. If you think about it, where am I going to put the last carbon? There's really only one place to put it. Here. Now, you can put it here if you like, or here if you like, or here if you like, but then that's the same thing. You'll know it's the same thing when you start naming it. Alright, so let's put those hydrogen in. My hydrogen is looking bad. That means I'm getting very lazy. Here's my longest carbon-carbon chain that has double bond involved. Ooh, how am I gonna name? How am I gonna number this? Am I gonna go left to right or right to left? Because when it comes to double bond, can you see it really doesn't matter, right? Well, still gonna be 2 and 3. So what are you gonna do? Well, if double bond can't make the determination, you look at what's important after that, which is side group. Do you want your side group to be at 3 or you want your side group to be at 2? That's your question. Because double bond can't figure that out for you. Well, I'm sure you guys know 2 is better than 3, right? So in this case, this is called 2-methyl. Okay, 2-butene. Very sick. Can I move this over here? 3-methyl 2-butene. I hope the answer is no. I really hope your answer would be no. All right. How was that? Okay. Are you guys comfortable yet with alkene? So, how about this? How about we clear this page? You just keep writing along. Okay. Let's do C6H12. I want you to pause this video and I want you to do this and I want you to return and see if you got the same thing I got. How does that sound? Okay, so pause now. Okay. I hope you're done and you return. So I'm going to be very, very lazy. How lazy? I'm not even going to do condensed formula. I'm just going to write C's because I know that you know how to insert H's. So here it is. Okay, C6H12. If you're not comfortable, go ahead, add all the H's. I'm sure it's going to be 12. So, name for this guy is called hexene. We know that hexene is not good enough. 1-hexene, because the hexene is between carbon 1 and 2. Okay? We have another hexene. But this time, this is a 2-hexene. Because the double bond is between carbon 2 and carbon 3. And we also have 3-hexene. Because the double bond is between carbon 3 and carbon 4. 4-hexene? I don't think so. Alright. Hopefully you guys got these 3. Now let's put some side group into this. First, we have a 5-carbon side group with the double bond between carbon 1 and 2. So this is going to be a 1-pentene. Side group, I can put over here. Okay, this will be called 2-methyl 1-pentene. Okay, well, let's keep this 1-pentene party going. Just change where the side group is going to be. So we have 3-methyl 1-pentene. Can I move it another carbon? Sure. Because it is very different here. This is not the same as this. Oh no. Okay, this is called 4-methyl 1-pentene. Okay, so that's 6 isomers all together already. Oh, there's more. Oh, there's more. This 1-pentene, I can keep the party going. Okay, well, not for 1-pentene, but maybe for 1-butene, right? Why not? 1, 2, 3, 4. Double bond between carbon 1 and 2, so that's a 1-butene thing. I can put 1 carbon here and put 1 carbon here. That's fine, because if you look at this carbon have exactly 4 bonds. It just won't connect to any hydrogen. Hey, you're going to get C6H12. Trust me, you are. So, making sure that this is your longest chain and this is the numbering involved. This is going to be 2, 3, remember di? Okay, dimethyl 1-butene. Okay. Do you think there's another 1-butene? Yes, there is. Look at that. Look at that. 3,3-dimethyl 1-butene. Okay, if you don't know where the 3,3 came from, this is where it came from. Okay, carbon number 3 has 2 methyl group. Okay, it's pretty cool if you think about it. It's actually pretty neat. All right, so Do you think there's one more? Question is, can I actually do this? Check this one out. There's a 1-butene. Can I do this? I don't see why not. If you think about it, okay? Because you want to make sure that your longest chain contains carbon-carbon double bond. So no matter how you put it, it's going to be the same. Now the question, can you do this? Because some people may say, oh, this is 5 carbon. Well, if you do this, this double bond C is a side group. No, the rule says your longest carbon-carbon chain has to involve double bonding. So this is the last actually, 1-butene. Okay, and to name this is called 2-ethyl 1-butene. Okay, pretty cool. Okay, what about double bond between the second carbon and the third carbon? Is there going to be a lot of those? It seems like, whoa, for the 1 and 2, there's like 1, 2, 3, 4, 5, 6. Am I going to have another 6 of these? Oh, don't worry. You're not going to have another 6 of those. I really should make this for homework, huh? All right. Let's do a 5. Okay. And let's insert some side group. The first one, I'm sure you guys will think of this one. All right. So this is called 2-methyl 2 pentene. Okay. Obviously, I can move that side group over here. This will be different because this is 3-methyl 2 pentene. Okay. I can move it over here. Right. And this is going to be 4-methyl 2 pentene. Okay. So hopefully you guys are understanding it quite easily. Let's move up a little bit. Okay. Let's move a little bit. There's butene. Can have C here and C here. Okay, this will be C6H12, and this is 2,3-dimethyl 2-butene. All right. And thank goodness this is it. You're not going to make any more of these double bond between the second and third carbon. Okay, because you can try. Okay, if you think that there's one more that I haven't shown here, I mean, be my guest. Show me. Okay, usually in school, if we were to do this live together, okay, I would have put some money on the line and say, hey, if you can find one more that I didn't find, this $5 is yours. Can't do that now. Maybe you could do it through PayPal or something like that. But yeah, if there's more, let me know. Okay, put it on the comment section, and see See if you can win see if you can win $5. All right. What about the blue? What about 3-hexene? Okay. Can I put some side group and make something different? Well, think about it. You really can't. You really can't. Why? Because if you do this, let's say. Okay, here's your pentene. Think about it. This is already a 2-pentene. Where are you going to put that side group? This, if you're going to put some side group in here, we already did that right there. All the one in red, we did already. So there is no more isomers. Okay, all the isomers have already been taken care of in this case. But it's pretty interesting if you think about it. So how many do we have here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 isomers for C6H12. So if somebody were to say C6H12, man, that person has a lot of problem because there's 13 different ones just right here, right now. Not to scare you or anything. I can find more. In fact, I can find a lot more. So, for today's homework, here's the challenge for you. C6H12, right? All right, okay. We figure out 13 of these alkene. The key word is alkene. I'm going to tell you right now, I can draw a whole lot of C6H12. There's more. I want you to figure it out, and we'll take it up tomorrow. What are the other ones? Okay, so think outside the box. Trust me, we've done it before. Make sure you name them too. And we'll talk again tomorrow. Bye.